Hello and welcome to the GCSE Chemistry tutorial for topic C7 Organic Chemistry. This tutorial will cover part 1, crude oil, hydrocarbons and alkanes. We'll also be looking at fractional distillation and cracking. Throughout the organic chemistry topic, we'll be looking at homologist series. These are groups of chemicals that have the same functional group and so react in a similar way. We'll be looking at alkanes, alkenes, alcohols and carboxylic acids over the topic. So what are hydrocarbons? Hydrocarbons are compounds that contain carbon and hydrogen only. This compound is a hydrocarbon because it's only got hydrogen and carbon in it. This one isn't because it's got oxygen in it. Crude oil is a fossil fuel found naturally under the sea. It is a mixture of hydrocarbons. To get the useful fractions from crude oil, it has to be separated by fractional distillation. Alkanes are examples of hydrocarbons. They are saturated hydrocarbons because they have no double bonds. Each carbon makes 4 bonds. These are the alkanes that you need to know. The start of the alkane word represents how many carbons there are. Meth means 1 carbon, eth 2 carbons, prop 3 carbons, bute 4 carbons. Alkanes have the formula CnH2n plus 2. What that means is the number of hydrogens is 2 times the number of carbons plus 2. So for example, ethane, if you take the number of carbons, which is 2, times it by 2 to make 4, and plus 2, 6. And here's a drawing of ethane here. You need to know the molecular and structural formula of the alkanes. When alkanes burn, they undergo complete combustion. That means there is a good supply of oxygen. The formula for this is hydrocarbon plus oxygen makes carbon dioxide and water. Here's an example of methane burning with oxygen to make carbon dioxide and water. It's also been balanced to the same number of atoms as is on each side. So let's go back to fractional distillation. This is a way to separate out crude oil to get the useful fractions from it. In fact, crude oil is useless. You can't use it unless you separate it out into the fractions. And each fraction is collected at different boiling points. The crude oil is heated until most of it's turned into a gas, and the gases then enter a fractionating column. In the column there is a temperature gradient, so it's hot at the bottom and gets cooler as you go up. The longer hydrocarbons have higher boiling points. They condense back into liquids and drain out of the column at the bottom. The shorter hydrocarbons, they've got lower boiling points. They condense later on near the top where it's cooler. So you end up with crude oil separating out into different fractions. As you go up the column, the carbon chain gets shorter. That means the boiling point decreases. The hydrocarbons also become less viscous, which means less runny. And they also become more volatile, which means they more easily turn into a gas. You will need to know the names of these fractions. Starting at the bottom, bitumen is used for roads and surfaces and roofs. Then there is heavy fuel oil used for ships, diesel, which is used for cars and trains, kerosene, fuel for aircraft, petrol, fuel for cars, and then liquid petroleum gases. There's more demand for the short-chained hydrocarbons compared to the long ones. In other words, the shorter ones can be used for things like fuels and making plastics. So cracking is a way in which you can split up the long chains into shorter ones. With cracking, you start with a long-chained alkane, and when it's cracked or broken down, it produces a shorter-chained alkane and an alkene. Cracking involves very high temperatures and a catalyst like aluminium oxide. Here we can see hexane has undergone cracking to produce butane, which is a type of alkane, and then ethene, which is an alkene. So you can see that the number of carbons and the number of hydrogens on each side will be equal. Pause the tutorial and try and answer these questions now. The first four alkanes are methane, ethane, propane, butane. Why is cracking needed? Because there's more demand for the shorter chained hydrocarbons. A use of bitumen for tarring roads and roofs. How do hydrocarbons change as you go up the fractional distillation column? Well, the chains get shorter, the boiling points decrease, they become less viscous, and they become more volatile. They also can ignite more easily. In summary, we've looked at crude oil and hydrocarbons, alkanes, fractional distillation, properties of fractions, and cracking.